Hello everyone, it's Peter. Welcome you back. Today we will go through the DynamoDB, very important AWS service. So this is for data source, or sometimes we call data power. We already introduced the different kinds of database, like the relational database, what we used before, like Oracle, or the embedded database like H2. They are relational. And then second one is like MongoDB is based on JavaScript. And then this one now in the market is more and more popular. It's called the DynamoDB. DynamoDB. So if you have experience with Amazon shopping, online shopping, and all their database are using the DynamoDB. Okay. So DynamoDB is based on the key value pairs. It's key value pairs. It's not a relational table. It's just simply key value pairs. So it's scalable and it's very fast. When we say key value pairs, so we can think about it as a hash map. So in the advanced Java programming, we talk about the internal process of the hash set. For each element of hash set, first you have to calculate its hash code as an integer number, and then use a hash function to map it to a bucket. And we will start from there because this operation is a big O of 1 time, running time. So it's very fast. Then after you go to the bucket, then you do whatever you like for this bucket. And DynamoDB is the same. DynamoDB, it has two keys called the partition key and the sort key. Partition key is like the key in the hash map. So you can use a hash function to map this partition key to a bucket. And in the bucket, there are lots of records. Those records will be sorted by the sort key. So sort key is like our primary key in a relational table. And the partition key is to specify what kind of table do you like. So it means that in one DynamoDB table, it may contain many different tables in a relational table. Theoretically, we can do that, but in the real project, we still need to build different tables. But the partition key is a good strategy to divide for different tables. So if you create a table, you may only have partition key without a sort key. Or you can have both partition key and sort key. So if you only have partition key, then partition key should be unique. If you have both partition key and sort key, then the combination of the partition key and the sort key should be unique. So if you use PK and SK together, so it's like the composite primary key in the relational table. So if you know the concept of the primary key in the relational table, so it could have the composite primary key. Okay. But it's similar, but the concept is different because the internal process is so if you do some search, you need to provide a partition key. And then after this partition key, and then you will go to the bucket. In the bucket, then this bucket becomes a small table, and you sort, you find the records based on the sort key. So let's make some example, and then we will go through those concepts in the DynamoDB table. So I'm logged in, so you can type DynamoDB, and you can go to the DynamoDB. Okay. And then go to the tables. Okay. Now, here I already created a student table. That's what I did before. This table is very simple. So you click the table, you can explore the table items, and you can run it. It's scan run it, go through all the records. So we have two search criteria, strategy. One is called scan, one is called query. Scan is to go through all the records. So usually the performance is bad. If you face a very big table, you use scan. And the query is based on the index. And by default, the index is like if you use query, by default the index is the partition key and the sort key. Now, if I use scan, you can see this table, ID is the partition key, and name is an attribute. It's not a sort key. So ID and name, ID and name. Okay. This is partition. So in this table, we only have one partition key. We don't have a sort key. Okay. Now I'd like to create another table, and we will go through the process of how to create a table. So we can create a table. So I will create employee table, which is mapping to our employee services. Okay. So the partition key, you can use any name, but I would rather use the PK as the partition key and the SK as the sort key. SK is sort key. So in PK, the DynamoDB only supports like string, number, and boolean. Okay. So basically, PK I use a string, and SK I can use a number. Okay, you can binary as a number. Okay, this one is also the three types. It's a number. For all other types, they all basically use string. So number I can use the like our ID like 100, 200 as the ID of the student, and the PK I will give a fixed value, say profile, as a fixed value. And then this is the default setting. And default setting, we have read capacity and the write capacity. Both of them are 5. Both of them are 5. The capacity mode is provisioned, is provided. And then you can use customize setting. Customize setting, so you can use standard and provision. So you can define your proper your read capacity and the write capacity. Maximum is what, the minimum is what, all those things. Okay. Now, before that, we need to explain what's the read capacity and the write capacity. So it is related to a very important concept. Let's come back to this one. There's a read capacity and write capacity, and a strong consistency and a permanent consistency. We know in database, consistency is a very important concept. So for example, so one transaction is updating a record, and another transaction is read the record. So if you don't control the consistency, it means that you might read the old data or you might read the new updated data, right? So the data may not be consistent. If you want to make it consistent, so when you write some data, you will block the reading. After writing is finished, is committed, then you can read it, then you read the latest data. So strong consistency and permanent consistency means strong consistency is that you have to read the latest data. And the permanent consistency is, if it's permanent, is finally you will read the latest data. But at this time, at a specific time, you might read the bad data. So it means that if I want to update some record and you read it, you might read the dirty data or the legacy data or the old data. But after you read several times, after some time, and then finally you will read the good data, the latest data. This is called permanent consistency. And the strong consistency means that you will wait until it is committed, and you will always read the latest data. This is called a strong consistency. So if you compare the two concepts, which one is faster? Permanent consistency is faster, right? Because you don't have to wait. But the strong consistency is a little bit slower, right? But if you see the data accuracy, so permanent consistency does not have data accuracy. It might read the dirty data, and the strong consistency will read the latest data, the correct data. Okay. So the two consistency will be related to the read capacity. So let me give an example. So assume I have 10, I need to read 10 records. Each record has, say, 6 kilobytes in 1 second. Like 1 second, I want to read 10 records, and each record has 6 kilobytes. So now the case one. Case one is strong consistency. Strong consistency. What is the required read capacity unit? So here is the read capacity unit RCU. For strong consistency, what is RCU? Based on the definition, if you search online, so RCU means that 1 RCU equals to 4 kilobytes per second. You read 4 kilobytes per second. Now, here you read 10 records, each record has 6 kilobytes. If 6 is not the multiple of 4. So can we do it like 10 times 6 is totally 60 kilobytes, and divided by 4 kilobytes, which is equal to 15 RCU. Is that correct? So I think this is the wrong answer. That's not the way it works. The correct way is that, so each record is equal to 6 kilobyte, which is equal to 2 RCU, right? So because it's one RCU can only read 4 kilobyte, but you have one record has 6 kilobyte, so each record will occupy 2 RCU, and then totally is 10 records times 2 RCU, which is 20 RCU. This is the correct answer. This is the correct answer. Okay, this is a strong consistency. Now, let's say case 2, permanent consistency. Permanent consistency, so the 1 RCU means equal to 8 kilobyte per second. 8 kilobyte per second. So you have 6 kilobytes. So how many RCUs? Is 10 RCU is required for permanent consistency, right? For each record, you need 1 RCU, and then you have 10 records for 1 second. So you need 10 RCU. So this is RCU. What is WCU? WCU is write capacity unit. WCU, 1 WCU means write 1 kilobyte per second. So if we use the same assumption, so assume I need to write 10 records, each has 6 kilobyte in 1 second. We know writing is much slower than reading, so then it need 10 times 6, just 10 times 6 equal to 60 WCU. This is write capacity. So this is, I think, if I'm an interviewer to ask you about the interview question about the DynamoDB, I will ask you the concept of the RCU and the WCU and the permanent consistency and the strong consistency. So they are the basic concept in DynamoDB. Okay. Now this is explanation. Then let's come back. So by default, the AWS give you 5 RCU and 5 WCU. Okay. So if you want to change, you can change. You can customize setting, and you can you can go to a maximum capacity unit. You can update that. You can update that. Okay, and then let's use the default setting. Okay. Then there's auto scaling. This auto scaling is on. Okay. And then others, you can add a new tag. I don't need to add a tag. Then I just create this table. Okay, it's creating, and let's wait for a while. So here is the read capacity is 5, write capacity is 5. Okay, so now it's active. Now it's active. Now go to employee. Employee. So we can export the table items. So now is nothing here. So we can create an item. Let's create one. So there are different formats to create this item. Let's say PK. I just use the fixed value, say profile. Profile. SK. Let's say 100. I can add a new attribute. I want to add a string. The value is name. Name. Let's say I just change another. I don't use Alice. I use Alex. Then add a new field is called a number. So as I said, so basically it supports string, number, boolean, those things. And I think one more maybe is the timestamp. Let's say salary. Salary. Let's say 53,000. This is the number. Okay. So this is the format that you can see. It looks like it's like a row in the table, right? That's the attribute value, and you can add more attribute. It's very flexible. You can add more. So this is a big difference between the DynamoDB and the relational table. In the relational table, you have to design a schema. The schema will tell the system what's the how many rows do you have. Sorry. How many columns do you have? What's the type of each column? Primary key, foreign key, those things. But for DynamoDB, it's very flexible because the record is in the format of JSON. So now we can go to the JSON view. JSON view with DynamoDB JSON, so it will give the type. Like x is the string, n is the number, s is string, n is number. You can also change it to this one. This is a normal JSON. Okay. Sorry. Now for the normal JSON, so this is very clear. It's the key value. So each record is the field name, field value, field name, field value, all those things. Okay. Then, but let's go back to the DynamoDB JSON. So even everything is in string, right? Even n is a string. So this is important when we want to do the search. So we will search with the DynamoDB JSON, not the normal JSON. But the return value will be the normal JSON and will be cast to our Java object. Now this one, I just create an item. I just create one item. That's good enough for this one. Okay. Now let's come back to the view table details. And the table details, we have indexes. So we have two types of index called global secondary index and the local secondary index. Why we say secondary index? Okay, index is a very important concept in relational database. Like in Oracle, the index is very important. So we have a primary key, but like primary key is a custom ID, so people may not remember their ID. They will search by their name, search by their social security number, or search by their address or other field. So if you search by other field, primary key is sorted. So you can use binary search to sort it. But if you search by name, the only way is you can scan the whole table. If you have 1 million records, so it's very, very slow. Excuse me. Now, next, you can create index on the name, so such that based on the index, the name will be sorted with a different primary key. Index is like a different primary key. And then you can also use binary search, so it will speed up your search. So index here is the same. The concept of index here is the same in DynamoDB. You have a global secondary index and a local secondary index. What's the difference? So first, I explain the definition of secondary, because the first index is your PK and SK, right? You can search by the PK and SK. They are like PK. You can cast to a bucket, and SK is sorted, right? So then you can use binary search, so it's very fast. Now we use a secondary index. Secondary index, you can define a different PK and SK, different from your PK and SK. And the local secondary index, it means that you cannot change your primary key, but you can change your sort key. So in this local secondary index, you don't change your primary key, but you can change your sort key to some other attribute. And the global secondary index, then you can change both for both primary key and sort key. In our class, I don't apply the global secondary index or local secondary index, because it will be charged even if it's in the free tier. For example, if I create an index, okay, I can give a name, like I use the name as the index, salary as I just give an example, and you can give index name. You can use your own index name, and then okay. So here there's a cost, right? Estimated cost 1 month with 2.91. With the reader and the write capacity. It's based on the capacity, so it will have, because why it has additional charge, because it needs extra space to contain those index. Then you can create index, but you have to be charged for this cost. So now I just cancel it. I just give you a concept. So in the real project, you might need to based on your search criteria, if you frequently use some field or some attribute to search, so you'd better to build index, global secondary index or local secondary index on that field. So this is the concept of the index. Now let's go back to the overview and explore table items. Now this is pretty much about this one. We explained what is a primary key, a partition key, and a sort key. What is query and scan? Query is query on the index. If you don't use any index, then use the primary key as a query. For example, let's come back to this one. Go to employee. I view table details. Okay. Explore table items. So if I scan, I just get all the records. If I use query, you have to input the PK. So then you can run it. And you can also add a sort key. Sort key you can use equal to, and the sort key value is 100. It's also the same record. Okay, so you can also add a filter. If you don't use sort key, okay, then I delete it. So PK and SK is related to the keys. Okay, so this is called the key condition. Okay, and you can use others. For example, you can add a name, attribute name. Name is equal to the Alex, then you can run. Okay. If you use something wrong, different, then there's no record, right? So you can see in the query, first you can use the PK and SK. You must provide the PK if you use query. And here you can select your index. Now I use employee is the own PK and SK. But if you have index, it will show index in the drop down. If you use the index, then you have to use the index primary key and sort key, not its own primary key and sort key. For example, the index, if the index is PK is name and the SK is salary, then the PK has to input the name as a PK. Okay? So with the index. So this is some queries in DynamoDB. At the beginning, if you are from the relational table, you need some time to get used to this DynamoDB. After you use it a lot, you will like this database. So it's really a very, very good database, DynamoDB. Now, next, I will go to our code to change our DAO object to connect to DynamoDB. How to do that? Let's come back here. Because the code is very complicated, and the configuration and the search code is complicated, I cannot write in the class. So I create a branch called feature DynamoDB. I prepare this branch. So, and I also have another branch is release 1.0, which is copied from the master. How to copy the branch? You can say branch. You can create a branch and create branch from some branch. So from master branch, you can give a name, some name. So then it means you can copy master branch to this branch. So that's what I copied. So I have two release. Let's come back to the source. Usually I don't use master. I have two release. One is release 1.0 is copied from master. And I will have a release 2.0. Release 2.0 will connect to DynamoDB. So, but I will use this one as my backup. This one. Okay. Now in our code here, I will in the team, I will switch to new branch. I just release 2.0. So after I finish this code, I will upload this code to the branch, and I will delete the feature DynamoDB branch. So then in the EMP services, you will see branches, three branches. Release 1.0 is using the relational table embedded database H2, and release 2.0 will use the DynamoDB. Okay. All the APIs is the same. I don't change anything. And there's another special branch, is feature test branch, is to cover all the unit tests. So later on, you will understand why I don't want to combine the test code in my branch, because if I change my code, all the tests will be changed. Otherwise, all the tests will fail or some compile error. So I just put the branch ahead. Okay, then I just finish. Now to make this work, the number one, I need to add a POM. Okay. Now let's go to this one. So to understand the code, I want to use the pull request to compare their difference. I can create a pull request. It's from let's say from the feature branch to let's say to release 1.0 branch. Okay, so this branch and this branch, I can see the difference of the code. Okay, so this is the difference. Now, so we have lots of difference. So the first thing is the first difference is in the POM. In the POM, I will have this one, DynamoDB, and I will need to remove the data JPA. So let's do this. I don't know if I copy this will be something wrong. let's do this. The JUnit, okay, here, and that doesn't look good. Okay, let's use a different way. I just duplicate. At least I compare the difference. I can okay. I can go to the DynamoDB branch. I will copy from the POM code directly. So in this POM, first I need the DynamoDB. I copy here. This is DynamoDB, and then I need to remove the data JPA, right? So I don't need this data JPA anymore, and I don't need H2, right? So I don't need the embedded database. Okay. Okay. Let me do this. Okay. Okay, this is the dependencies. Okay, others I don't have to change. I just save it. Now you can see there are lots of errors. Okay, don't worry about that. First, I will rebuild the entity. Rebuild the entity. So I will go to the entity part. EMP. This is DB entity. Entity. So to make it look better, because this is DB, I will change this to DynamoDB. Okay. But anyway, I will do the entity first. This is employee entity. I will copy the code. Okay. Now I want to explain. So this is entity class. For one, there's annotation for the DynamoDB table, and the corresponding to the table name is employee. So this is very straightforward. So I give because all our PK will be profile. So I give a static field called a default profile. This is a constant. So we define PK and SK and the and setters. Other field doesn't matter. Okay, but I want to have the PK and SK with different annotation. This is DynamoDB hash key, like our hash map, right? Hash key is the PK, and this is a range key. Range key is sorted. It's a range, so it's SK. Add two annotation to specify my attribute name, and other attribute name I don't have to change because this name necessarily is mapping the table attributes. But PK and SK I need to specify PK and SK for this one, for hash key and range key. This is the entity P. Okay. Now next we go to the DAO. Okay. Now in the DAO, let's see. Upper level, go to the DAO. In the DAO, I will add the this is the purely interface. This interface is find by name. It's the same name, find by name, find by salary, and update salary. But now update salary by name is void, and save in the data JPA it returns the entity, but I save then I use void. Delete I also use void. Okay, so I only change the DAO under the DAO package, DynamoDB package, and I don't want to change anything on the service side or the upper side. So I will keep all my code the same. Here, it's better to change a different reflect rename. I change DB to DynamoDB. Okay, to make sure this is DynamoDB. Okay, and for this DB, and also reflect rename DynamoDB. Okay. Now, next I will do the implementation. Okay, new class employee down import. Okay, usually I use this naming convention, import, and the interface is employee down. Okay, I want to implement the 5 methods, okay, by default. So for this class, I need to add a repository. So we mentioned this before in our Spring class. This is a stereotype, and the system will automatically create this one. Repository. Yeah, so it wait for a while. Now, before we can use all the code, we need to change some config. First config, so this one is in the Spring data GPA, so I can delete it. And the entity scan, I don't have to scan it anymore. Okay. And here I delete it. Now this config, the entity scan will be deleted. This config, let me go to the config part. Main config. So, okay. Let's go to the DynamoDB source main config. Okay. Now I will copy all of them, then I will explain to you. I also need to add all the import. This is DynamoDB entity. Okay. Now let's talk about the config. Configuration command scan is the same. Now I need to import access key and secret key because I need credential. So for this one, I then in the application YAML. This one I don't need this data source part. This is all gone because I don't need the relational table. And then after that, I can add the resource key. Let's see. Let's go to the source main resources. Let's go to this one. Spring config, log config. Oh, so it's still the old one. Sorry. So this one, source main resource. Yeah, I need to have AWS config. So this is my AWS config. I need to input my real access key and secret key later, but now as a public repository, I just use it as secret. So you need to replace it with your own access key and the secret key. Okay, this is the application of YAML. And after that, the data and the schema, the tool one will be deleted. I don't need this one. Okay, so then this value will be imported to this config. Now, with this config, I have credentials. So this is a basic AWS credential provider. So this is credential. And with this credential, I can have a DynamoDB here. So the code is use the builder. So you can later on you will find all the AWS services. They will have some builder like step function builder, like a batch function builder, and the SQS builder, and the S3 event builder, and so for each AWS service, they will have some client builder and with the name. This is Amazon DynamoDB client builder standard. With standard, then with credentials. So all of the clients will have the standard and with credentials. Or it may have there's a method called the default client. What is default client? Default client will read from your local config file, AWS config, to read your local credential. And the credential is a big topic in AWS. So we can search for credentials, AWS credentials. So that's the yeah. So let's read this one. Okay. So the official website has understand AWS credentials. There are different ways to do the credentials, and then you can read the official document, how to access it. Okay. I don't want to go through. So if you have interest, so credentials can be imported into from the application.yaml, can be used default client to read from your local AWS config file, or you can use the environment setting to set the credentials. There are lots of ways. There's some hierarchy or precedence to do what one is first, what one is second. Finally, it will find your credential. If you cannot find it, it will say you don't have any credential and it will have access denied. Okay. Now, let's move ahead. These credentials. Then after you build the Amazon DynamoDB client, and then you can go to the DynamoDB mapper. With DynamoDB mapper, it should be good enough, but you want to, this mapper can map any table. But if you want to map this table related to your entity, so this is, I use this DynamoDB mapper, and this is another one. I give this, I change to employee entity mapper. Okay, with DynamoDB mapper. So we can, so this mapper, this DynamoDB table mapper is related to the corresponding table, but you can also use DynamoDB mapper directly to read or write your records. And here I use a bin name. Actually, I don't have to, but in the real practice, you have to define this name for different mapper because you might be connecting to different tables. So each table have a DynamoDB table mapper. So there are more than one object of DynamoDB mapper. So you need to give a name and use qualifier to specify what mapper you want to relate it to. Okay, so it's this one. So then we finish the config. So in our code, I only need to use this mapper. So this is the conditions. This is the preparation of how to build a DynamoDB client and DynamoDB mapper, and finally go to the DynamoDB table mapper. Okay, I will use this table mapper. So let's come back to this one. So let's read the main. This one and the db down import. So at the beginning, I add this. Okay, so this is log. Okay, here is this log is this 4J, this one, and this is auto while, and the qualifier. Right? This is what we learned before, and this mapper is I wrap this mapper inside. This is a mapper. Now let's start with find by name. This code. Let's say something simple. Okay, let's delete. Delete is the real simple one. I just use mapper dot delete an entity. That's it. Nothing special. And the entity, the save. If you have an entity, but if you convert, if you map an employee to an employee entity, the problem is it doesn't have a PK and SK. It only have a name and salary. We have to provide a PK and provide a SK. So I will talk about later. Now, next is update salary by name. So this one can be used for the first one, find by name. So this one is also easy. So first we can get employee entity equals to find by name. Right? I can find by this name, and then entity dot set salary is entity dot get salary plus increased salary. Right? It will be increased. And then finally, I will use the mapper.save, save entity. So I think this code is easy. Plus increase salary. Something wrong. Yeah, I've copied. Okay. Now we will focus on the logs. Okay. Now let's do the first one. We have a log. Let's copy the first one. I will explain the code. Find by name. Okay, this is a map. Hash map. attribute value. This one, this is expression, and yeah, this class util. Okay. Now I like to explain the code. It's a log. Now attribute name. So we have PK and name. So I want to find by the name. So first the PK should be the profile, right? So here the value. They are attribute name and the value. Name is key and the value is the value, key value pairs. So with different one, I give this one with the value. This with S is the string, with N is the number. So the string is with the primary key is always the default PK, and the name is another value. So when we do the expression, so first we new DynamoDB query expression. This one, I just shift with key conditions. So we have two conditions. One is key condition. Do you remember we talked about this key condition here? We have key condition with PK or SK, and then with filter condition, right? So that's the same. Key condition is a PK corresponding to this PK, and the column PK is the value, the corresponding value, and the sharp PK and this pound sign PK is corresponding to this PK. Okay. And the filter condition is with name equal to this name, and with expression attribute name, and with expression attribute value. Okay. And then you want to find only one with limit one. If you don't give a limit one, there could be multiple records. Okay. And after you get this expression, and then you map the query expression, and you get entities, and you might get nothing, right? If you get a null entity, an empty entity, then it means you cannot find this one is written null. Okay. And then this is return zero, gets 0. So in the service side, employee service, let's say, if you search by name, so in this map, it will, I think it's already identified as null. If it's null, it's false, right? So that's good. So we don't worry about this null value. So this is find name. So we have a key condition, we have a filter condition. Okay, key condition for keys and the filter condition for other values. Now similarly, we can do the same thing for the find by salary. Okay, now let's copy this code. The difference is we have minimum salary and maximum salary, right? And with n, this is with n inside is still a string. So we talk about this one. This is DynamoDB JSON. Let's run this record. And if you see this file and with JSON view, in the DynamoDB JSON, this is with S or with N. S is a string. N is also a string, but finally it will be translated to a number. Okay, that's why our code is here. Actually, this code is very straightforward one-to-one mapping with the console. In the console, what you can see, then you can do the same thing with some API in Java. So then I just go to that one. And for update salary, I also use debug. I need to add a log to make things easy. Update employee with the name to increase salary with salary. So I just add the name and the increased salary. Also has some type of this one, increased salary. Okay. Now save. First, we need to add the PK. The PK is employee entity dot default PK. Now for SK, that's a problem. So let's add the log. Save employee. I just add this entity. Because I want to add this entity, I need to override the toString method. Okay. Open the declaration. Finally, I add toString so that I can toString method so that you can see what record you add in the CloudWatch. Right. So, and this is delete. Delete employee. Now let's talk about the ID part. So the ID part, we need to find the maximum ID. Okay. And then maximum ID plus 1 will be the new ID for the new employee. So I will create a method for find by max ID. Find max ID, I will add a method for this. Find max ID. So int let's say integer ID is equal to find max ID. So entity.setSk will be the max ID, will be ID plus 1. Okay. Like max ID plus 1 will be the sk. After that, just a mapper.save entity. That's it. Okay. Now, this is find max ID is the same. We have PK, and for this PK, I get all the records. And then here I should add some attributes. So with scan index forward. So by default, it's sorted by the SK, and then I can with scan index forward. Then will be the I think is so the scan index will be the from small to highest or from high to small. So I'm not sure about that. Let's say it's false or true. Okay, so I want to get the maximum value. Maybe I don't need this anymore. So it's like if you want to output your records in a increasing order or decreasing order based on the SK. Okay, based on the SK, and there's a true or false. So I don't know which one is correct. I will try some example and prove that. Okay, and then I get this entity. If it's not empty, means there's some record inside. I get this one because there's only one record. I get SK. Otherwise, if the table is empty, I start with 100. So this is the ID. Now, okay, let's do it. And I will also cut my video for the secret key part. Okay, welcome you back. I already updated my credentials, and then we can make a test. Let's run it. Okay, let's clear this one. So we can use our already created the EMP services. Let's start from scratching. Hello is a simple one. I just run it. It will get hello. So let's skip this one. Now let's go to the search part. By name. The first one is Alex. Let's run it. So you can see Alex 53,000 is here. And from the log, you can see a get request to search by name and find the employee with name Alex in DynamoDB, right? So you can see the logs here. Now, if I find somebody else, if I find ABC, then should be false. Employee not found, right? It's the same. So this is a search. Salary part I will do it later, and then I want to add some employee. So let's add some employee. Say Tommy, 75,000. Let's add it. So it's successful. Then after you add it, let's go back to the table. I can run it. Let's go to scan. Let's just run all the records. You can see Tommy is increased by 1. That's one record. Now I want to add another one. I want to save another one. Say it's Cindy 92,000. Let's do it. This is 2. And then let's refresh. is 102. It means in this DAO info, this force will sort will be this force will be the I think is the decreasing order. So, yes, by default is true. By default is increasing order, and if you set this to false, it will be decreasing order. Decreasing order I will with limit 1. It means that only get one record is the first record. The first record will be the maximum with the record with the maximum ID. So I think that is correct. Now after you after you already saved after you already have 3 records, let's compare the salary between 50,000 and 80,000. Let's run this one. Let's go back to the search tool. So it's between 50,000 and 80,000. Let's run it. If we go to it, so it's Alex and Tommy, right? So now next, you can delete it. You can delete by name. Name is Alex. I will delete Alex if I call it. So it will be deleted. And then we go back to the profile and I run it. So it's deleted. Yeah. Then we prove that this code is working, and later on I will submit the code to my Bitbucket, and you can for you to check out. So basically, the DynamoDB. So the easy one is to writing process. You can save, you can delete, you can update. So it's very easy. The search part, the code is a lot. So you need to use attribute names within the map and the attribute values in another map. Right? So for the name, for the DB query expression, you divide it by the key condition or with a filter condition, filter expression. Now you understand what is key, what is filter. You cannot mess up. If you use filter condition if you put PK in a filter expression, that will be wrong. You will have error. And with that, you can also have another one is. So this one expression, this one you can do with index name. Okay. With index name, some GSI index. If you create index, I just use a comment here. Add index for search. If you create a secondary index, you can add index name here, and then the key condition, the condition will be changed. For example, if your index, the PK is name, then the key condition will be name, and maybe the filter condition will be the PK. Did you get the point? So it's based on how you define your index, like a global secondary index or local secondary index. So I just make a comment here for your reference. You can use index name here, and others I think already explained very clear for this example. So this is pretty much about DynamoDB, and after we finish DynamoDB, then this is a whole story of our REST API. We have a Spring Boot app with REST API, and then we have DynamoDB. And later on, I will deploy my Docker image as a 2.0 version to my ECS. So I will show it next time. And the procedure is the same. And I will launch with the new service. Okay. Thank you very much.